So good morning, ladies and gentlemen. As I will talk about two sides of LCA and input-output. One is what Bo said, input-output as a data source. But I will also talk about a study that we did with my former employer, because I'm not anymore with UNEP, Bo, but I'm now at the University of Bordeaux, here actually in France. So I will provide two sides. One is input-output to actually use it in a life cycle perspective to say something on the environmental impacts of consumption and production, and the second aspect to use it as a data source, in a hybrid way for LCA studies. So first, this UNEP report is about assessing the environmental impacts of consumption and production, coming up with priority products and materials. It's based on input-output tables. And, I'm presenting here jointly with someone, Sue, who was a co-author of this report. And, at that time in UNEP, I was the person following with a colleague, the completion of this document. So this report looked at 4 different questions and using 3 different perspectives to actually answer the questions: what are the relevant environmental impacts of consumption and production, not of one particular product, but at the broader level of the whole economy. So, and here, it was a life cycle approach being used, but it was cut off, as you see here, at 3 levels. Once it was looked at a production perspective, so the aggregation of the input-output data were just done only up to the production side. The second one, then the whole life cycle was aggregated from the input-output using a consumption perspective, and moreover, a material flow information was used to also address a materials use perspective to see also which materials have the highest impact, because this was considered also of interest for certain governments who are in the steering committee of this international resource panel. Moreover, the question was tried to be answered: what are really relevant impacts? So what are the key environmental resource pressures that need to be considered? So here you have the methodological framework. So it's using the so-called driver pressure state impact response model, and you are using here in the area of the drivers the life cycle approach, and then you are looking what from the pressures, which pressures actually are responsible for which impacts and are more relevant, and at the same time you are trying to see what are the environmental impacts or the sources of environmental impacts that matters at the materials, production and consumption perspective. I'm just running now quickly through the results. So the most relevant environmental impacts being highlighted, are the ones that are very familiar to you because it was in LCA perspective being used, is here climate change, habitat change, including land water use, eutrophication, urban and regional air pollution, indoor air pollution, and other toxic emissions, and from the resource depletion side, fossil fuels and some metals, plus unsustainable fish harvest. This report was, using not doing original new research, but just reviewing existing literature. From the production perspective, it was mainly the processes involving fossil fuel combustion having impact on climate change, air pollution, and eutrophication, and then the agricultural activities using biomass impacting water, land eutrophication, and toxicity, and finally, fishery impacting biotic resources depletion. From a consumption perspective, and this is more similar to the European IPRO study, it looked at the whole impacts, life cycle impacts of final consumption, informs policy and consumers on areas of a desirable shift to low impact products and sustainable lifestyles. And here, food, mobility, and housing came up that they drive more than 70% of impacts. Another important point at the international level that came up, that pollution embodied in trade is increasingly relevant. As said, moreover, two approaches were used to also address the topic of the materials perspective. So studies that were using material flow accounting were analyzed, and the method developed between CML and Wuppertal Institute on environmentally weighted material consumption was also used. So this came up actually that not all, approaches that especially looking at physical material flows are, not the same as if you look at environmental impact approaches. So especially also not only at carbon, but if you take into account other environmental impacts, in particular, bio-based materials show quite a high environmental impact. So the conclusions were that the consumption materials perspective point production consumption materials perspective lead to the point that agriculture and food consumption jointly with processes engaging fossil fuels, in particular in the consumption clusters mobility, housing, and energy, are most relevant. And there is, from policy side, the challenge, that new patterns of consumption and productions are needed because impacts rise with income. So how is this, a challenge to be addressed? And also, that a global perspective is needed because trade is relevant for decoupling. From a methodological side, it was said that better data and harmonized data are needed, especially across countries, because at the end, the study was mainly done with US and European and Japanese studies, and not so much from developing countries. However, it was said that developing countries, in principle, mobility as a consumption pattern would be less relevant, and food in relationship more important. Actually, the study, we have here Michele from the European Commission. So according to what I've heard from a colleague from you, this study has had some influence on putting food as one of the topics really higher on the agenda in environmental policy. So you see that such studies with input-output data, what you might think from a more engineering, natural science-driven way, they are not reliable because they are not precise, but they are the data that policymakers use to calculate all major statistics, including the ones on GDP and so on. And this is where they base their policies on. So it's quite convincing for them to use those data in the context of policy making here, but with a life cycle perspective. The other topic, and you already mentioned this report, Bo, where input-output now is mentioned, input-output tables are mentioned, is actually as a data source in this global guidance principles for LCA databases, because there is a whole chapter on what is called adaptive approaches, where it said that stakeholders' needs and demands are evolving. Additional information is allowing both old and new questions to be answered. And here, one of the key the new data sources is actually to use national statistics as one element, as Bo said already in his speech, for converting them and using them to have more information, what that is missing for life cycle assessment data on the product level. So this is in principle the structure of the economy that is reproduced here by different tiers related, but all on economic flows, and then environmental information is added to these input-output tables. And the input-output LCA already has been, similar to what Bo said. It's already in the 90s, this has been discussed, similar to this question of consequential attributional, but now it has become a more and more useful element of lifecycle assessment, and currently input-output databases are included in commercial LCA software packages as a source for data to enable hybrid analysis. So the applications of input-output tables in lifecycle assessment is as a background system for sector-specific environmental characterization and as a reference in analyzing lifecycle assessment system boundaries. What is the benefits of a hybrid lifecycle assessment? Well, the number of processes linked to a product system is huge as the supply chain propagates. So here it's a question of the truncation, so how much you can cover additional information by input-output, information from input-output table. It is very difficult, if not impossible, to gather process-specific data for all processes involved. So here again, the question of cutoff, we have this here. We have a very simple life cycle, and you make your boundary around, but in the real economic context, of course, all those different systems and are interrelated and are propagating, and the question is, you always cut up at a certain level. I mean, a very known example is the one of business travels that hardly are considered in process-based LCAs, but they also have an impact and are part of business and indirectly of the production chain. So we have two sides of the same coin. It's about accuracy versus precision. So high precision is put forward by a process LCA. However, the input-output data provide a higher accuracy because they're very inclusive, but you cannot really bring them down to the level of an individual unit process, what is at the end the core of an LCA databases. So these are the two areas, and this also has implications for uncertainty. So a process lifecycle assessment, the strength is process specific. The weakness that you have to cut off, so you have truncation. The input-output LCA is encompassing, system boundaries, but you have the problem of a huge aggregation, so you don't have the information with the same precision at, the product and unit process level, and especially, the smaller the quantity of the product goes or the specific process, the less you are able to use these data for this purpose. That's why the idea of hybrid LCA is developed, that combines, process-specific, the strengths of the process-specific lifecycle assessment, and also encompassing system boundaries, so that you try to minimize the weakness. Still, let me finish that there are other limitations also of input-output lifecycle assessment, that the input-output industry classification distinguishes generally less than 1,000 industry and commodities, but you have, of course, much more if you really want to do a process LCA, and you have an assumption of linearity, and you have a commodity homogeneity and also a price homogeneity, because you always have to link the prices back to the environmental impacts through factors, and this adds, of course, also additional uncertainty. The data in input-output statistical data are usually several years old, and there is a huge uncertainty also to the topic of imported commodities. With this, I would like to change. I have to finish. I have just here added some further, tools and data sources for input-output tables and for also environmental extended input-output tables, plus, available tools that are available for input-output and hybrid LCA. Actually here the CMLRA, Sigma Pro and CEDA 3.0, and I think Econvent is now also having some of those data, or it will take them up? Not yet, okay. Question for, clarification, don't hesitate to bring it up now.
Yes, I have a question. Actually, I was involved in a similar project as you
Confidentiality.
We couldn't use the direct data by the Central Bureau of Statistics. We had to, make some sort of calculation and then work with those data, but we never could see the core data. So I'm really intrigued by how you are putting that into, LCA programs like CIMAPRO.
But the CEDAR is mainly based on the US data that have a higher resolution than generally in Europe. So, and then they aggregate directly the environmental and impact factors, and this is where someone who has done this work in this area where special expertise needed, where I'm not gone into the details here.
Thank you.
Yeah, there's another question.
Olivier Muller, PwC. You mentioned that input-output tables usually have a limited number of data, less than 1,000, you said. Are you aware of initiatives which would improve the quality of this data, especially the number of initial tables, to make it more precise?
Yeah, there are activities ongoing in different, parts. We have heard from the Netherlands, but also at the European level and elsewhere to increase to make the maximum out of the existing number and to extend it to especially have a coverage of what you call 80% of the world trade, because in principle here the environmental impact is related to the economic activity.